Now that we've completed straight line graphs, now we'll look at some parabolas. Parabolas are curvy graphs, so they either look like a happy face or they either look like a sad face. So those two types are parabolas. So let's have a look. Starting with question 15, it says sketch y equals to x squared, expressing the x, y, and the vertex. Okay, so x-intercept, y-intercept, and we also have to find the vertex. Do you guys know what vertex is? Vertex is simply the tip of the parabola. So if I have a parabola that looks like that, this is the vertex. And you should also know the formula for this vertex. Okay, for those who've forgotten, I'll let you know now. Vertex is when x equals to negative b on 2a. You have to memorize this, guys. This is a new formula. Vertex formula, negative b on 2a, where b is the coefficient of x and a is the coefficient of x squared in any quadratic equation. Okay, so hope you get what I mean. So I'll just write that equation for you. Sorry, it's slanting. See, if this is y, see this equation here? The coefficient of x squared is a, coefficient of x is b, and the constant is c. But we only need to worry about b and a. Okay, so let's start with this one. See how it's y equals to x squared? Same with any type of parabola, like similar to the straight line graphs. If there's nothing adding or subtracting or something that's following it, if it's just y equals to something x squared, the center, or sorry, the vertex is always going to be at 0. Okay, so over here. But still, please write this down because we're going to use this for the next few questions. So for this particular one, let's have a look. Similar to the straight line graphs, to find the x and y intercepts, we always sub an x equals to 0 to find the y-intercept and y equals to 0 to find the x-intercepts. And if you do it, you'll see that it's just 0, 0. That's why the intercept is at here. Okay, so I've got that, and that will just be the vertex. And y equals to x squared is positive, x squared is positive, so it's going to be looking like that. A happy face parabola. Okay, and that's it. That's the most basic parabola you can ever get. So have a look. And there's no really need to label anything because the x-intercept, the y-intercept, and the vertex is all at the origin. So no point of you labeling anything. And make sure you got this down because this is important. Okay, so now that we've done the first one, let's move on. Okay, y equals to 2x squared. Y equals to 2x squared, we have to know how to compare it with the x squared graph because from a distance, they just look exactly the same, but you need to know that slight difference. So, if this is x squared, the one that we drew in the previous question, question 15, this question is simply got a 2 in front, so the coefficient becomes 2, whereas this one is 1. So if it's 2x squared, what does it look like? I'll show you. It's a lot narrow. It's a bit more narrow than the y equals to x squared graph. And again, guys, you can test points by subbing in x equals to 1, 2, whatever you like, and then find the corresponding values of y and join them. That's still fine, but I don't want you to do that all the time because it's too time consuming. So make sure you know how the graphs differ and how the shapes differ. Okay, so again, as the coefficient of x squared becomes bigger, the more narrow it is. Okay, if it's less than 1, say between 0 and 1, it becomes fatter. Okay, so if it's say like half x, it will be a lot fatter this way. Okay, so that's the difference. Sorry I did that really rough, but that's the whole idea. Hope you get the basic idea. That's y equals to 2x squared, the yellow one. Let's move on. Y equals to negative x squared, what do you guys think? Well, if this is y equals to x squared, the one that we drew in question 15, the basic one, if I have a negative in front of it, simply turns upside down into a sad face parabola. Okay, just like that, just the opposite direction. So that's question 17. Question 18, sketch y equals to negative 2x squared. Okay, well, I'll start off by drawing the negative x squared graph that we did in the previous question. So you all know how to do that. And the only difference is that it's got a 2. Okay? Like the straight line graph, if it the integral number becomes bigger, remember the straight line graphs, it became more steeper. Look, this one with parabolas, if the integral value of the number becomes greater, then it's a lot more narrower. Okay, so that number, if it becomes bigger, narrower. If it gets smaller, fatter. Okay, so that's how you can remember it. Okay, have a look. Okay, question 19. Sketch y equals to x squared plus 1. Okay, and we're going to express all these. Okay, well, I'm going to start off by showing you the y equals to x squared graph. I always like to compare it so you can see the difference. Now, all the difference is that we're adding 1. And remember with the straight line graph, if we're adding 1, we simply lift it up by 1, wasn't it? We shift it up. Same with the parabola and any type of graph. I'm just going to shift it up. The intercept becomes, see how the vertex was at 0, 0? Now it becomes at 1, so around there. So, you join it. Sorry, it's a little bit lower. There. So it just becomes shifted up by 1 unit. That's the only difference. Okay, and then that applies to all graphs. So, hope that helps. Question 20, x squared minus 1, what do you guys think? If that's the y equals to x squared graph, y equals to x squared minus 1, we shift it down by 1. So my new intercept becomes negative 1. I'm just calling it intercept, but it's the same as being vertex and y-intercept, x-intercept's all the same because of, because the origin was the intercepts and the vertex originally. So if I move it down by 1, simply shift it down by 1. Okay, so the new vertex becomes over here. Okay, so just label it as negative 1. And before we move on, I also want to find my x-intercepts. See how the x-intercepts here? We have 2 x-intercepts. Okay, whereas previously it was just at the origin. Now we have 2 x-intercept values. And the y-intercept is just negative 1. Same with the vertex. How do we find these two? Well, like the straight line graphs, to find the x-intercepts, we let y equals to 0, don't we? So I'm going to go ahead and do that. So let y equals to 0. So 0 equals to x squared minus 1. Let's factorize this, guys. X squared minus 1 is x minus 1, x plus 1. Difference of 2 squares. If that's equal to 0, what's x? X is positive 1 for this one, and x is negative 1 for that one. So this point here, it's negative 1. This point here, it's positive 1. So you should label it as well. Okay, it's important for you to label everything. So, can you see that? So I've got it all. And we can move on. Question 21. Y equals to negative x squared plus 4. Okay, well, this is the negative x squared graph, just the upside down, the sad face parabola. And if it's plus 4, what do? Shift it up by 4. So if this is the vertex becomes shifted up by 4. So it becomes up here. Like that. Okay, well that's pretty fast. This should be 4. So it's lifted up by 4, and that's just it. And we also need to express our x and y intercepts. Y-intercept and the vertex is both at 4. We also need to find these 2 points, don't we? Sub in y equals to 0 to find the x and y intercept. X-intercept, sorry. 0 equals to negative x squared plus 4. Okay, now it's not a good idea to have a negative in front of your x squared. So I'm going to multiply everything by negative 1. So this still becomes 0. This becomes a positive x squared. This becomes a negative 4. Okay, so factorize it again, guys. This one is difference of 2 squares again. X squared minus 2 squared. So let's factorize it. X plus 2. Okay, so what are the values of x? Positive 2, negative 2. So this one is negative 2, this one is positive 2, so I've labelled it and that's all done. Okay, so that's my final graph, the yellow one there, and my intercepts. Okay, so get that one. And let's move on. y equals to negative 2x squared plus 8. Alright, I'm going to do the same thing. Start with my negative 2x squared. Now, you know the difference between negative x squared and negative 2x squared? Negative 2x squared is a little bit more narrow than the negative x squared graph. So I try to draw it a little bit more narrow, but as I said before, you can't really tell a difference, so just going to be rough. Okay, so that's my negative 2x graph, hoping that it looks a little bit more narrow. And we're lifting it by 8 because it's plus 8. So this is our vertex now at the origin, so it becomes lifted up to 8. So I lift the graph up and it should become like that. Okay, so my new y-intercept and vertex is at 8. And again, we need to find our x-intercepts. Easy stuff. I'll still try to do that. Y is going to be 0 to find the x-intercept. And then I'm going to divide both sides by negative 2 because negative 2 is common, or 2 is common, and I don't want to have a negative in front of my x squared. So I'm going to divide everything by negative 2. This still remains a 0. This becomes x squared. This becomes a negative, and 8 divided by 2 is simply 4. Same as the previous question, isn't it? X minus 2, x plus 2, 0. So x is positive 2, negative 2. This is negative 2, this is positive 2. So you know how to do all this, right? Without my help. This is just easy stuff. So have a look at that one. That's my final graph. Okay. And let's move on. Question 23. Okay, y equals to x squared minus 2x minus 3. What I'm going to do is start off by finding the x-intercepts. Okay, because that's what we usually do. And this one is a little bit difficult to think about the shift, how it shifts, because it got a 2x. Remember in the previous questions it was just something x squared plus something or minus something, but this has got a x term in there, so it's going to be difficult to do that. So we're going to do it this way. Find the x and y intercepts first, like we usually do, similar with the straight line graphs. So the x-intercept is when y equals to 0, sub in y equals to 0, and what I did here was just factorize it. Factorize this, you should get that. Okay, easy stuff for you guys. And then what would x be? 3 and negative 1, so I just plot the points in. Okay, so this is our usual stuff. Now y-intercept, sub in x equals to 0, so you have 0 squared minus 2 times 0 minus 3. Just calculate that, you should get negative 3. So I just plot that in there. That's my x and y intercepts all plotted in. Now all I need to do is find the vertex, right? And I told you the vertex formula. I'll write it again just for the sake of those who don't remember. Minus b over 2a. X equals to minus b over 2a. Remember, that's only the formula for the x coordinate. So if you want to find the y, you're going to first find the x and then sub it back into the equation to get the y. But I'll show you how to do that. Okay, so to find the vertex, I gave you the formula, same as that one. So b is negative 2 and a is 1, isn't it? Put it in. So negative 2 over 2 times 1. Okay, where b is negative 2 and a is 1. Just find it, calculate it, you should get 1. Okay, so I've got my x coordinate of the vertex, which is 1. Now we need to find the y. So all I need to do is substitute that value of 1 back into the original equation, or the graph. Okay, so put it back in. You have 1 squared minus 2 times 1 minus 3. So you just put the values of 1 to x, and then you should get negative 4. Okay, so that's x, that's y. So the coordinate would be 1, negative 4. I just plotted there, so it's approximately there. Okay, so I've got my x, y, vertex. So all I need to do now is join it. So I'm thinking it's gonna look like that. Yeah, have a look. Happy face parabola. Okay, that's it. So you just need to put a bit of effort finding the x, y intercepts and the vertex, and not forget this formula. Straightforward, let's move on. Question 24 says sketch y equals to 2x squared minus 2x minus 4. Okay, I'm going to start off by finding the x-intercepts again. Sub in y equals to 0. 0. And I just factorized it. And as you can see, if I let it be equal to 0, I can divide everything by 2 because 2 is common. So this will become, well, I'll write 0. 0 equals 2x squared minus x minus 2. Do you see what I mean? If I let it be equal to 0, you can just divide everything by 2. And then this one gets factorized into something like that. Okay, easy factorizing. And what's x? X is simply positive 2 and negative 1. Plot it all in. Now, I need to find my y-intercept. Sub in x equals to 0 into the equation, into that original equation. Sorry, I'm just not going to confuse you. And then you're going to get that 2 times 0 squared minus 2 times 0 minus 4. Calculate it, you should get negative 4. Plot it in. So as soon as you get more information, just plot them in as you go. And finally, what do we need? We need the vertex. So we're going to use our x equals to negative b on 2a formula. B is negative 2 and a is 2. So I'll go minus negative 2 over 2 times 2. Just put in your values and calculate it. You should get a half. Okay, easy stuff. So I've got my x coordinate of the vertex as a half. We need to find the y coordinate now. So sub that back into the original equation. Just like, well, I just subbed it in and then I'll skip all the algebraic steps. Just put it in, guys. Just be careful and you should get negative 9 on 2. Okay, I'm just going to skip all the calculations because it's just a lot tedious, but do check and then see if you get that one. Okay, by putting half into the values of x. Easy stuff. And then what's your coordinate? This is your y, this is your x. What's your final coordinate for the vertex? Half and negative 9 on 2. And I just put it as a decimal because it just takes too much space. So x is half 0.5 and y is negative 4.5, which is the same as this. So I've got my vertex, my y-intercept, my x-intercept, and if I join it, I think it will look something like that, similar to the previous question, I think. Yeah, like that. Whoops, got the vertex in the wrong position. Have a look. Another happy face parabola. So again, as you can see, just follow strictly the steps. X-intercept, y-intercept, and the vertex. That's all you need to worry about. Okay, so let's go on. Okay, question 25 says, sketch y equals to x squared plus 2x plus 3. Okay, now I'm going to start with our usual procedure, start with finding the x-intercepts where y equals to 0. Now, have a look at this one, guys. This one, if I let y equals to 0, I can solve for x, like that, right? But I was trying to factorize this. Can you factorize this, guys? The factors of 3 are 1 and 3 only. Now 3 minus 1 is 2, but in that case this won't be a positive, isn't it? So because I'm using 3 and negative 1, 3 times negative 1 is not positive 3, it's negative 3, so we can't factorize it. So what I'm going to do, if that doesn't work, what I'm going to do is probably use the quadratic formula or the completing the square method. A lot of you guys will start going to the quadratic formula, and that's fine, but I'm going to show you a little method we're using the completing the square method. So I use completing the square by going x squared plus 2x, so I write up to there, and then remember with the completing the square we always look at the coefficient of x. So the coefficient of x is 2, we divide that into half, so we divide that into 2, sorry, and then square it, right? 2 divided by 2 is 1, 1 squared is just 1, so I added 1, and because I'm adding something I'm going to subtract it back, so eventually 1 minus 1 is 0. It's like it's nothing there, but I'm just putting it in there to complete the square. So if you're adding it, make sure you subtract it right after it, and then I'm going to plus the remaining 3, and I'm simply going to group the first 3 because I did that to complete the square. So this part will simply become x plus 1 the whole thing squared, a perfect square, and then negative 1 plus 3 is simply 2. Okay, now I'll show you why I'm doing this. Have a look, guys. X squared plus 1 squared this is a positive number, isn't it? Anything squared is always going to be positive, yeah? That's a positive number, and if I add 2, it's going to be even more positive. So this whole thing here, guys, is greater than 0. Yeah, can you see that? Now if it's greater than 0, whatever value of x I put in, it's always going to be greater than 0. Okay, so it's basically the x values is all real values of x, all real x. So all these values of x make this happen. Okay, so can you see that one? So what I'm going to say is, if this is this original graph or equation, yeah, this is this, and I said that this is greater than 0. So this whole thing is greater than 0. That means the graph is above the x-axis. Okay, it's not going to be equal to 0. It's going to be something greater than 0. So if the graph must lie on the top part. Okay, because this is the part. This is representing y. Y is this. This is greater than 0, as I explained here. So the whole graph must be above the x-axis. Okay, so we don't have any x-intercepts. There's no x-intercepts. Okay, now I'm going to find the y-intercept. So sub in what x equals to 0 into there, and like this, and solve it. You should get 3, so I just plotted 3. And of course, finally, we need to find the vertex. So sub it into your x equals to negative b onto a formula, and b is 2, a is 1. So just put it in, 2, 2, 1, and then you should get negative 1. Okay, and sub it back into the original equation to find y. You should get y is 2. And I'm not going to go through that procedure. You can just go ahead and try that yourself and check if you get this. Okay, so put negative 1 into all your values of x to find y equals to 2. So our vertex is simply negative 1, 2. That's the coordinates, so I just plot it there. It's a good idea to use points so you can just like join it. Now I've done that. All we need to do now is join the graph, join the points. So I've got 3 and I've got the vertex, and I know that the graph is going to be on top of the x-axis, and I know that it's going to be a happy face parabola because the coefficient of x squared is positive, so it's simply going to look like that. Okay, and see how it's not touching the x-axis? Because the graph is positive, greater than 0. Okay, there's no x-intercepts. So have a look at this one. It's a quite unique question. Okay, so check that out and let's move on. Question 26 says, sketch y equals to negative x squared plus 3x plus 5. Okay, so I'm going to do our usual thing, start by finding the x-intercepts. So sub y equals to 0, and what I'm doing here is actually using the quadratic formula, as you can see, and that's because it doesn't factorize. Okay, I can tell you that now, it doesn't factorize because, well, first of all, what I would suggest you to do is get rid of the negative. Okay, so I let y equals to 0, and I'm going to divide both sides by a negative 1, so that becomes, because I don't like to have negative in front of my x squared, so that becomes negative 3x minus 5. Now the factors of 5 are 1 and 5 only, but that's not going to make negative 3 at all in any way. So I'm going to try to use the quadratic formula, okay? And I should have explained this in the previous question, but remember we used the completing the square method? If you use the quadratic formula, that's still fine, but you'll probably end up with a negative inside your square root. Okay, that indicates that we don't have any x-intercepts again, because we cannot have negative inside the square root. So if you get that, as soon as you see that, you know that there's no x-intercepts. So it's kind of the same thing, but I use the completing the square method because that shows you if it's going to be above the x-axis or below the x-axis. Okay, but because it was greater than 0, it was all above the x-axis, right? So yeah, just a bit of a late note there. Anyway, let's get back to this. This is simply using the quadratic formula where a equals to negative 1, b is 3, and c is 5. So I just put everything into your quadratic formula, and I'm not going to go through that process because we've done the heaps of that before, right? So just put it in, and that's what you should get. Now, I don't like having negative on the denominator, so I'll multiply everything by -1. So it becomes positive 3 here, and this plus and minus sign, if you multiply positive with negative, it becomes a negative, and if you multiply negative with a positive, it becomes negative with a negative, it becomes a positive. So I kind of like switch the plus and minus sign upside down, but it means the same thing. Okay, and then square root 29 over positive 2. So I just changed this to this form, and I labeled it for my x-axis, my x-intercepts. So it's going to be 3 minus root 29 on 2 here, and 3 plus root 29 on 2 here. And what I like you to do is try to put each of these values into your calculator and convert it to a decimal, and check approximately exactly where it's about on the axes. Okay, because if you just look at that, you don't really know where about it's going to be. So put it into a decimal first, plot it in the right spots, and then label it like that in the exact value form. Okay, so just a little thing there to note. Okay, now that I've got the x-intercepts, let's go ahead and find the y-intercept. Sub in x equals to 0, this is the easy part. Just sub it in, and you should get 5. Okay, so plot 5, and then the vertex, use that formula, so this should be stuck in your head by now. A is -1 and B is 3, so just plot it, sub it in, and you should get 3 on 2. Okay, so sub that back into your original equation to find your y coordinate for the vertex. So go ahead and sub it in. I'm not going to go through that procedure. I got 29 on 4. Okay, that's the easy part. You can probably just use a calculator, I guess. So I got that one, so that's my coordinate. Now I just converted it into a decimal because this is just taking up too much space. So I put 1.5 and 7.25, just converted it into a decimal, and I've got my vertex. Okay, and as soon as you see the vertex is up here and the rest of the points are out down here, you probably can see that it's going to be an upside down parabola. But how do you actually determine if it's an upside down parabola? Look at the coefficient of x squared. It's negative, isn't it? That means it's a sad face parabola, an upside down parabola. So as soon as you see the coefficient of x squared is negative, it's going to be upside down like that. Okay, can you see that? So it's passing through the x-intercepts, the y-intercept, and the vertex. So it's going to be like that. Very simple, but this bit is probably a little bit annoying, so just beware. Have a look at that, and let's move on to the next question. Okay, sketch y equals to -4x squared plus 4x minus 8. Okay, I'm going to do my usual process of starting with the x-intercepts by subbing in y equals to 0. Have a look here, guys. I'm going to try to do what we do, let y equals to 0, and then I'll just write it all down first so you can see. And as you can see, they're all multiples of 4, so I can probably divide out by 4, and then I can, oops, sorry, that's a plus, isn't it? Okay, divide everything by 4, and then I don't want a negative in front of my x squared because that becomes difficult to work with. I'll divide everything by -4, okay? So this becomes still 0 equals to positive x squared negative x plus 2. Okay, so I switched all the signs and I divided everything by 4, sorry. So I've got that. Now, see if you can factorize this one. The factors of 2 are 2 and 1 only. And I guess 1 minus 2, so positive 1 minus 2 would make -1. But positive 1 times -2 is not positive 2. Okay, positive 1 times -2 is -2. So that doesn't work out. So basically we can't factorize it. So what do we do when we can't factorize? Yes, you can use the quadratic formula, but this one I want to use the completing the square method again to show you. Okay. Firstly, I divided everything, I factorized everything by -4. Remember, with completing the square, the coefficient of x squared must always be positive 1. So it can't be -4. So that's why I'm factorizing by -4. So I have x squared minus x plus 2 remaining in the brackets. Okay, let's perform our completing the square method. This is what I did, and I'll show you. I actually kind of skipped a step, so I'll show you over here, and I'll show you how I got to this step. Now, it's going to be -4 x squared. I always write up to my x, And then what's the coefficient of x here? It's -1, isn't it? So it's plus -1 divided by 2 squared. Right? You always square it. And then I'm going to subtract it back. Yeah? Subtract it back and then add the 2. Do you see what I'm doing? So make sure you always, when you add something, you can't just add something randomly. If you're doing something, you must subtract it back so it's like the original equation. And then I add the remaining 2. Now, this becomes, I'm going to group this part. This one, factorize it. Remember, whatever's inside what we square goes here. Okay, so I put x minus a half, the whole thing squared. Okay, and you can just calculate this, guys. Negative a half squared plus 2 simply becomes 7/4. You can calculate that easily, so I won't go through all that. That's how we get to that. Okay, have a look, guys. Look at this. Is that a positive number or a negative number? It's something squared, so it must be positive. Anything squared is always positive, so that's positive number. And if we're adding a positive number to a positive number, it becomes even more positive. So this whole thing here is greater than 0. Okay? But if I multiply that to -4, if I multiply a positive number to a negative number, the whole outcome simply becomes negative or less than 0, basically. Does that whole thing make sense? Okay, take it step by step, and if you don't get anything, you must go back and check because this is important. So that's what I got. I got that this whole thing is less than 0. So basically, this is our original equation. So our original equation is just less than 0, which means everything is less than 0 below the x-axis. Okay, so everything, all the graph must lie over here, nothing on top. And because everything's less than 0, there's no x-intercepts. Nothing is going to be intersecting with the x-axis. Okay, so that was the whole point of this. You won't get all this idea if you just use the quadratic formula. So I suggest you to use the completing the square. Okay, now let's go on to our next step by finding my y-intercept. So sub in x equals to 0. This is an easy step. Just sub it in, get y equals to -8. But make sure you still get this and check you get this, okay? Because I'm going through this very quickly, so make sure you get the same outcome as me. So I point that in, and finally my vertex. I did this very quickly again because this is very repetitive, but you just simply use your x equals to -b on 2a formula. And a is -4, b is +4. Just put it in, find your y, that's what you get. So if you'd like to have some practice, just pause and see if you get that. So just check and see if you get the same answer as mine. Okay, because it's important for that to be correct as well. So I've got my vertex, I've got my y-intercept, and I know that there's no x-intercepts, and I know that it's going to be below the x-axis. And if the whole graph is to be below the x-axis, it should be a sad face parabola, right? Because if it's a happy face, it would be intersecting, wouldn't it? And I can also tell that it's going to be sad because the coefficient of x squared is negative. That means it's going to be upside down parabola, just like that. Okay, so it's intersecting with the y-intercept, and there's the vertex. Okay, does that whole thing make sense, guys? And it's important for you to show this in your working as well. Alright? Have a look, have a close look at this question. It's a very typical exam type question. And that was some parabolas.